Alright, welcome back guys. We are now diving into 7.5 to explore some angle pairs. So the first thing we're going to talk about is review these words that we're going to use. So adjacent. Adjacent means right next to, touching, and with angles you have to share the same vertex. So one thing they like to do on standardized tests is they'll show one angle opening like this, and this might be angle 1, and they'll show another angle opening like this, and this side is a shared side, and they'll call this angle 2, and they'll ask you, are angle 1 and 2 adjacent? Well, they're touching, they're right next to, they're sharing a side, but they're not sharing that vertex, so they're not adjacent. So be careful, watch out for that, do not fall in the trap. Vertical angles, when I teach vertical angles, I like to talk about the fact that in geometry, have you ever seen Ender's Game? One of my favorite parts of that movie is when he says, well, there is no up in space. There's no direction, there's no gravity, so there's no determination of up. Geometry is just like that. I can take anything I want, I can turn it, I can change it. So when we talk about vertical angles, the easy way to remember this is these are vertical with each other. I can see that they're physically vertical with each other, but also angles 1 and 2, if I were to turn my object and turn that pair of angles, I could make them actually be physically vertical with each other. Big thing with vertical angles, they have to share the vertex, but they also have to share the same two sides that make up both angle. So if I look at the lines that make up angle 1 and angle 2, they're the same exact lines. So that's what you're looking for with vertical angles. With complementary angles, the way that I like to teach that, and I have a lot of corny memory tricks and I get that, I like to say to compliment somebody is the right thing to do. It's nice, you know, you want to be a nice person. So complementary, right, compliments are the right thing to do. Complementary angles add up to make a right angle, and one misconception with this is that complementary angles have to be adjacent. Those are adjacent and they're complementary. But these are not adjacent, but they're also complementary. So complementary and supplementary angle pairs do not have to be touching, they just have to add up to get the measure that we're looking for. Now supplementary angles down here add up to 180 degrees. So angles 3 and 4 here shown are an example of adjacent supplementary pairs, and making sure that's in the shot. And then angle C, if we look for angle B must have been chopped off, don't know where it went, but angle B, I could go ahead and draw this. Well, if that's 137, I could figure out what angle B is going to be by saying 180 minus 137. The 100s cancel out, and I get 43 is my answer, so B is going to be 43. So I'll draw an approximate angle here, and then we'll call it angle B. We'll say that that is the the supplement to C, because we know they have to add up to 180, but they don't have to touch each other. Perfect. All right, so give this a shot on your own. If you have not tried to fill in these notes by yourself yet, go ahead and try it. Pause the video because I'm about to roll on. So this says angles AFE and angles CFD are vertical angles. Is this statement true? I always like to highlight or color code or something so I can see what they're talking about. So AFE is right here, and CFD is right here. So the thing to check is, do they share the same vertex and do they share the same side? So when I check vertex, both of those angles share that vertex. When I go to check sides, I'm going to go ahead and highlight this. So CFD uses the line CF that continues on there. Ooh, I see that AFE also includes that line. CFD includes the line FD, and AFE includes the line AF. So these are vertical. They do share the same two sides. They do share the same vertex, and their measures would be equal. So we could go ahead and notate that will also be 62 degrees. Now BFC and DFE being supplementary. So I'm going to go ahead and wipe this away. So make sure, oh, there we go. So BFC and DFE, again, we need to locate them. So BFC is right here, and then DFE is right here. And to be supplementary, remember, they don't have to touch, so it's okay that these angles are not adjacent, but they do have to add up to 180. And when I look at 118 and 28, I can quickly identify that that is not going to add up to 180. So these, in fact, are not supplementary. Then it says BFD. So BFD, now we're talking about this angle. And AFB, so AFB, this angle, it says are adjacent angles. Well, to be adjacent, they have to be next to and touching, sharing the same vertex, and sharing a side. So we see that we have a shared common side right here with my line BF. We are right next to, we're touching, and we're sharing the same vertex. So, yes, this does meet all of the requirements to be adjacent. Those two angles are an adjacent pair. Make sure that was in the shot. Yep. Okay. So we now have to find a complementary angle to EOD. So again, always identify what angle you're first referencing or first starting out with. And I would suggest using colors on this. On my notes that I have here, I have all kinds of colors. If you can see, the quality is not very good, but colors will help you immensely when dealing with geometry. So EOD is what I start with. I need to find a complement. So remind yourself, complementary angles sum to 90 degrees. So to find that complement, we would need a 30-degree angle, but since none of my other angles are labeled by degrees except for my right angle, I can look at this and determine, well, if I have a right angle right here, that means that also this angle right here is also a right angle. Now that angle is a combination of two angles, so I can see that if I have this angle with my blue angle, then it's going to add up to be 90. So the complement here would be angle DOC. And if I'm looking for a pair of vertical angles, this is really convenient because I can actually keep my colorings up here. Remember, vertical angles have to share the same vertex, the same two sides, and they have to be equal to each other. So if I'm looking at sharing the same two sides, well, this side isn't going to work because it doesn't continue out here, so that's right out. Ooh, this side does work. This side does work. DOC I've already got, so the complement to DOC would be AOB. So we would say DOC and AOB. Those are my vertical angle pairs. So this is in your notes, so I'm sorry that the resolution on here is not wonderful, but there's some things that we can determine without markings, and there's some things that we totally have to have markings on our image to be able to determine. So without markings, we can determine adjacent angles, because while they're beside each other. We determine supplementary angles, because we're allowed to say that if a line looks like it's perfectly straight, it is perfectly straight, unless it's labeled otherwise. And you can find vertical angles because you don't need any markings for that. You just need to find these shared sides. Things we can't conclude without markings is if angles or segments are congruent. We need measures or we need notations that things are the same measure. An angle's a right angle. I have to have an indication for that. I have to be told that something's perpendicular. I have to have a right angle symbol. I have to have 90 degrees. Something has to tell me that. And if angles are complementary, I need to know something. So like in this last image, we knew that this was 90 degrees. That's what let me know that this was 90 degrees. So you gotta have some kind of markings to figure those things out. Make sure that that was everything. Yep. So here, take a moment and determine, can I make this conclusion from what I'm showing in the diagram? So am I allowed to say what this statement is with what I see in the diagram? So take a moment, try that on your own. First thing it asks us is TW congruent, because remember this symbol is our congruent symbol, is TW congruent with WV? Well, I see these markings right here indicate that they are in fact the same length, so yes, we're totally able to make that statement. Those markings on the image tell us that those segments are congruent. Now it asks PW congruent to WQ. So PW and WQ are both on that line. PW has no markings. WQ has no markings. Now it looks like they might be the same measure, but because I don't have any markings, I am not allowed to say this. There's not enough information there for me to figure that out. TWQ is a right angle. TWQ would be this angle right here. I'm not told anywhere that there's a perpendicular relationship here. I'm not told any degree measures, and I don't see any symbols that indicate any degree measures, so I do not have enough information. I cannot determine that. Now, D asks TV bisects PQ. Read that carefully. TV, this line, bisects PQ, this line. Well, since PQ has no markings on it, I can't determine what length PW or what length QW is, so this statement actually cannot be proven either. Now, the funny thing is, though, if I turn that statement around, I could say that PQ bisects TV, because I see that these are equidistant. I know that this is the midpoint, which makes PQ the bisector. So if I turn that statement D around and say PQ bisects TV, then we could say that yes, we can make that determination. Linear pairs. So angle pairs, when they become a linear pair, you can probably figure this out, means that they make a straight line. So up here, ABD and CBD form a linear pair because when they are connected, they make a straight line. Postulate 9 tells me that if it's the linear pair postulate. If two angles form a linear pair, then they're supplementary. Well, that makes sense because linear pair means straight line, and straight lines are 180 degrees from one point to the other when I open the angle. So then it says name a pair of angles that form a linear pair in the diagram at the right. And I have a few choices, so I'm going to show both different options. First one is kind of boring. I could say LMP, that right angle, and PMN. Those make a linear pair because they're both right angles. Or I could get a little bit more funky and say LMQ, which is this larger angle here, and then I could say QMN, which is this smaller angle. Those would also form a linear pair. So you have two different options for your linear pairs there, and of course your angles could be written in a different order than mine, or switched around in location. None of that would matter. Order is kind of irrelevant here as long as M, your vertex value, is in the middle of all of these angles, because for all of these, M is your vertex. So now our top problem here says ADB and BDC are a linear pair. So the first thing I do is think about that and say, okay, really I see a straight line here. I know A is over here, I know C is over here, and then there's going to be D is my vertex, and there's some line, could look like this, could look like that, could look like that. We don't know what it looks like yet. There's some line that then makes those two angles allowed to be a linear pair. So the first thing I think about is they're going to add up, make a straight line. So it says, what's the measure of angle ADB and BDC? So I'm going to get rid of this so I have a little bit more space to work. Because I see that they are a linear pair, that tells me they sum to 180. So I'm thinking in my head and I'm writing out, all right, ADB plus measure of angle BDC equals 180. So then I can replace ADB is 3x plus 14, BDC is 5x minus 2. That's all going to equal 180. So now I start combining my like terms. I will again highlight these to make it obvious. So I've got variable term, constant term with the negative in front of it. Always watch out for that negative. A lot of people will drop those. So 3x and 5x gives me 8x. 14 and a negative 2 give me 12. That's going to equal 180. Then to start my solution process and work towards isolating x, I'm going to get rid of the constant value first. So we subtract 12 from both sides. That gives me 168. I shouldn't be writing in red. and that's equal to 8x. Then when I do the division, I get that x is equal to 21. Now again, as I'm sure you probably anticipate that I'm about to say, we're not done. That is not our answer. We then take that value of 21 and plug it in to find those angles. So, if grading will work, yep. So, ADB, I'm going to start with, is 3x plus 14. Now I know that x is 21. So it's 3 times 21 plus 14. Which I know is 3 plus 14, which comes out to be 77 degrees. So measure of angle ADB is 77 degrees. We're going to do the same thing with BDC. Again, I can either measure and then the angle symbol or the angle symbol with the arc through it. So I have 5x minus 2, which is 5 times 21 minus 2. Hold this up. Yep. See what I'm doing. There we go. We have 105 minus 2, which comes out to be 100 degrees, and that is measure of angle BC has to be in the middle. And then because they're a linear pair, I know that they should add up to 180. Well, it just so happens 77 and 103 add up to make 180. So we know by that the work we've done is correct. Everything that we've done is good. So hopefully this all makes sense to you. So I'm trying to make sure you can actually see it. Hopefully this makes sense. Try the next problem there at the bottom of the page. Try that on your own. Make sure you're writing out all your work. Don't skip steps. Don't jump around. Take time to process through this well. It will help your learning. So pause the video. Go ahead and try this. I'm going to dive right into it after a bit of coffee. Alright, I've got all my setup here. And I look for my variable terms. I look for my constant terms. I combine all of those together. So 6n for my variable terms, 36 for my constant terms is equal to 180. I'm going to start my solution process with isolating the x. So I subtract 36, subtract 36. That gives me that 6n is going to be equal to 144. And then to get rid of that, 6, we divide by 6 on both sides. I gotta move this up. And that gives me that my value of n is 24. From there, we're going to plug that value in to find our actual angle measure. So remembering that n is 24, and come up and choose which one I start with. I'm just going to do EFG. So 2 times 24 plus 21, that's 48 plus 21, which actually comes out to be 69 degrees. And then we move on to GFH. And that is 4 times the 24 plus 15, which 4 times 24 gives you 96, plus the 15 gives us an angle measure of 111 degrees. So when I look at adding these two up, again 180, which tells me that yes, it is a linear pair. They are still supplementary. Good. So angle bisector. We talked about a segment bisector a couple sections ago. An angle bisector is exactly what you think it does. It is the ray that cuts an angle into two congruent pieces. So AY right here is that angle bisector. That ray that cuts the angle XAZ. It cuts that angle into two congruent pieces. So you can actually label it like that. So then I have a problem here. It says KM bisects JKL. And if JKL is 72, what is JKM? So to think about this, I really want to draw a picture first. So when I try to draw this picture, I have I'm gonna try to make approximately 72 degrees. So we know that's not quite a right angle. I'm gonna have J, K. I know K is the vertex because it's in the middle. L, and then I have a ray that is bisecting. That is KM. So I'm told that the whole thing is 72. Sorry, kind of writing a weird angle. If I know that the bisector cuts it in half. So this is going to be half of 72. If I calculate half of 72, it's going to be 36 degrees. 2 seconds. I'll be done here. Well, a little bit more than 2 seconds probably. All right, the last thing we have here is a diagram that angle bisector and a couple expressions that we have to solve. So because we have an angle bisector, I know that these two angles are going to be equal to each other. So I set up an equation. 3x minus 3 is equal to 4x minus 14. Now you have a lot of options. You actually have 4 options with how you could start. I like to start by putting my variable terms on the side where my variable is largest right now. So that's going to be the right side. I'm going to take 3x from both sides to get my variables over to the right side. My left side, I'm just negative 3. Do not forget about that negative. Negative 3 is equal to 1x minus 14. Of course, I don't have to write the 1 in front of the x. It's kind of like redundancy. Then to get my variable on the same side, I will add 14. And that is going to lead x equal to 11. Again, that is not my answer. Part of my answer. I'm going to come up here and choose either one of these to plug it into. So 3 times 11 minus 3. Well, that's 33. Minus 3, which is 30. And because we know that was a bisector, both angles are equal. If you plug in your 11 into the other expression, you'll also get 30 degrees. And then the final question here, measure of FGI. FGI is just a combination of those two angles. So it would be 30 plus 30, which is of course 60 degrees. So guys, please let me know in the discussion any questions remaining about this section. Otherwise, I'll see you in class. Keep working hard.